Hi everyone, this is Editorial for AtCoder Beginner Contest 188. Now first let's look at the problems. So problem A, 3-point shot. So a basketball game is being played and score is now x to y, and x does not equal to y. So can the team which is behind turn the tables with a successful 3-point goal? So this means first we need to find the smaller of the x and y, and we will try to add 3 to it and find that if it will be larger than the other one. So this is an easy problem. We just need to find max as y minus minimum x y. And we need it to be no larger than 2. In other words, we can simplify to absolute value of x minus y is no larger than 2. Now let's look at problem B, orthogonality. So we need to determine whether the inner product of vector A and vector B is 0. So we just calculate the inner product as the problem describes. So problem B. Just calculate Now problem C, ABC tournament. There are 2 to the nth power players labeled from 1 to 2 to the nth power. And each of the players has a rating, and any 2 players have different ratings. A match between 2 players always results in the victory of the player with a higher rating. And we need to find the player who will take the second place, that is, who will lose in the final match. So this is a very typical single elimination match. Here we will make an example of 8 players. So this is n equals 0. So first, 1 will play against 2, 3 plays against 4, 5 plays against 6, 7 against 8, and then the final match will be between the winner of the upper bracket and the winner of the lower bracket. So here is winner of upper bracket and the winner of the lower bracket. And there will be a final winner and a final loser who will take the second place, and we need to find this person. So we need to solve this problem in 2 steps. In the first step, we find the winner of the upper bracket and the winner of the lower bracket. Then we let these 2 winners play the final match and find the loser. So we just find the maximum of the upper bracket and find its index, and the maximum of the lower bracket and its index. And we compare the two winners and get the answer. Now let's move on to problem D. Snoop Pram. So in problem D, we need to use n services, and each service will last from the AI state until the end of the BI state. And we can choose whether or not to buy a subscription. With the subscription, we will need to pay C yen per day, and we can use all services. Otherwise, we will pay CI yen per day to use the ICE service. So in this problem, each service is a segment. And the services can have overlaps. For example, here and here. We can first consider for each day. We can find how many services we will use on this day. For example, on this day, we will use the service we will use the service 1, 2, and 4. And in this case, we can choose to pay C1 plus C2 plus C4. Or we can buy a subscription and pay big C. So we will compare these two and choose the smaller one. This is no doubt. However, in this problem, the endpoints of these segments can be as large as a billion. So we cannot calculate the answer day by day. Since there are only 200,000 segments, there are at most 400,000 endpoints. So we can find all the endpoints and split the whole period into several small segments. However, there is a problem here. For example, if the first service is from day 1 to day 5, and the second service is from day 5 to day 7. So when we have these two services, what segments will we get? Actually, we will get 1/4, in which we have service 1, and 5/5, in which we have service 1 and 2, and 6/7, in which we have service 2. So we can find that not only these numbers, 1, 5, 7, of course they occur in the final segments, Also, 4 and 6, they occur in the final segment. So what is 4? 4 is 5 minus 1. What is 6? 6 is 5 plus 1. So this means instead of 400,000, actually we can have as many as 800,000 endpoints. So besides AI and BI, we will also use AI minus 1 and BI plus 1. So the ICE service will give us 4 points. And we can do a discretization. We can do a discretization. And we'll get the final period with all these points. And this time, each point, besides the start and the end, each point owns the segment follows. So we will use 0, 1, 2, 3, 4, 5, 6, 7. Then for each part, we need to find out whether we should use the services, we should pay for the services separately, or we should buy a subscription. But we cannot afford calculating the parts one by one. What can we do here? Actually, we can use the difference theory. That means, for example, we have a service, AI, BI. And first, we will find the segment corresponding to AI. Then it is NP AI. Suppose we use a mapping called NP. And for the next part, since BI is included, so we will find the next one, which is BI plus 1. And its corresponding segment is NP BI plus 1. Then we will add to the diff NP AI. We'll add CI to it while we extract CI from diff NP BI plus 1. So this means if this service covers these 3 segments, we will add C1 here and minus C1 here. Then after we get the difference area, we can easily get the value of each part by simply accumulating the difference area. Now that we've got the value of each segment, so we call it accumulate 1, accumulation 2, and so on. We just compare this one with C and this one with C. And we use the smaller value. So the length of each segment is very easy to calculate. We just need to use the start of the next segment to minus the start of this segment. And we will get the length of each segment. Okay. Now let's go to problem E. Pedal. So in this problem, we have n terms and m rows, so that means we have a graph. Important thing here is that all the rows, they are directed, and it is guaranteed that xi is smaller than yi. So all the rows are from a term with a smaller index to a term with a larger index. That means suppose we have terms 1, 2, 3, 4, 5, 6, 7, 8, and all the rows are from a smaller term to a larger term, like this. So this guarantee ensures that there are no loops in this graph. And actually, the natural sequence of 1, 2, 3, 4, 5, 6, 7, 8 will be a valid topological sequence for this graph. And in this problem, we need to buy a kilogram of gold at some time and sell the gold in another time. Note that we cannot buy and sell in the same time. So there will sometimes be negative answers. How will we solve this problem? We can just go backwards. That means we go from the last term to the first term. Of course, we will first build an adjacency list from the edges given to us. And then for each term, for example, term 8, we try to find all the terms it can lead to. In this case, it leads to nowhere. So we cannot buy gold at term 8 because we cannot, otherwise we cannot sell the gold. But we can update the highest price of term 8 to its own price, A8. Then term 7, it's the same. We cannot sell here, and the highest price is A7. Then term 6, so it leads to term 8. So we can buy at ton 6 and sell at ton 8. So the maximum profit we can make is here the maximum profit is high 8 minus A6. So if 6 leads to more than 1 ton, for example, if there are ton 9, ton 10, and 6 also leads to them, we need to find the maximum of all the high values of its direct children. Then after this, we will update the high value of 6. So it will be max of A6 and the maximum of its children. Then we just continue our solution. Then from all the profits, we find the maximum, and that will be our final answer. Now let's go to problem F. Plus 1 minus 1 times 2. So in this problem, we have two integers, x and y. We have x and y. And we can do three types of operations. That is plus 1, minus 1, and times 2. And we want to transform x into y. So first, there is a simple case. Case 1, if x is larger than y or x is equal to y. In this case, we cannot use plus 1 because x is already larger than 1. We cannot use times 2 either. So we can only use minus 1. And the final answer will be x minus 1. Then the second case, which will be harder, is that x is smaller than 1. The naive solution is to use preference search. We start from x, then we try plus 1 minus 1 times 2, then we try plus 1 minus 1 times 2. But this solution can easily lead to a time limit exceeded. Why? Because there are 3 branches at each point. Can we do better? Yes, we can. We will still use preference search. However, we will start from y instead of x. So why is this different? Because now, let's see. So at this time, the operations are changed. So plus 1 becomes minus 1. Minus 1 becomes plus 1. and times 2 becomes divide by 2. So now, at each point, first, if at this point y is already smaller than x, we will directly update the answer with d, which is the distance until now, plus x minus 1. And in the second case, y is still larger than x. We consider 2 more cases. First, if y is even. Oh, sorry. Before we do this, we will also update the answer with d plus y minus x. That means we will go one step each, one step, directly to f. Then, if y is even, we only choose divide by 2. Otherwise, if y is odd, we'll try y plus 1 and y minus 1. So in this case, why don't we choose plus 1 or minus 1 when y is even? Because if we choose plus 1, since y is already larger than x, plus 1 will make y further, will make y more distant from x, and that's not what we want. And what if we choose minus 1? We don't need that because we have already considered that at this point we use d plus y minus x. So we only need to consider y divided by 2. So we can see that by reversing the order of the breadth-first search, that means we start from y instead of x, we have already cut many branches. So in this method, there will only be one branch if y is even, or there will be 2 branches. There will be 2 branches if y is odd. And in our naive solution from x to y, there will always be 3 branches. So this is a very big improvement. We can also stop the breadth-first search once the front of the queue is worse than our current answer. With this optimization, we can pass the time limit of this problem. So to make it clearer, we can look at the following example. So here we use x equals 3 and y equals 23. And we will start from 23, 0. 0 is the steps, number of steps. Then, currently the answer is 20. Since we go from 23 to 3, we use 23 minus 3, and we got 20. Now, let's move on. So from 23, 0, we can go to 22, 0. No, nope. It should be 22, 1. And 23, 24, 1. And these two cannot update this answer. Then we will come to 22, 1. Since 22 is even, we will go to 11, 2. And from 24, 1, we will go to 12, 2. So now we are at 11, 2. 11, 2, we will go to 10, 3. Oh, first we will update the answer. 11, 2. So 2 plus 11 minus 3 will get 10. By minus 1, we can go to 10, 3. Here we will not use plus 1 because 12 is already visited. And now 12 is even, so we will go to 6, 3. Okay. Then this is top. Now we are here. 10, 3. Can we update the answer? No, we can't. 10 is even, so we will just divide it by 2. We'll go to 5, 4. And now at 6, 3. 6, 3, can update the answer? Yes, we can. So we have 3 plus 6 minus 3. 6. And since 6 is even, we will go to 3, 4. And now it is popped. But now at 5, 4, can we update the answer? No, we can't. Since 5 is odd, we cannot go to 6. 6 is already visited, so we will go to 4. 4, 5. And it is popped. Now at 3, 4. So can we update the answer? Yes, we can. We can update it to 4. And now we're at a point that the final answer is as good as the point in our queue, as good as the front of our queue. So we can stop our breadth-first search and return this answer. And that's all for this example. So that's all for today's tutorial. And if you have further problems, you can comment under the video, or you can visit my website cpwiki.verso.app to leave some comments at the text editorial. Thank you for watching, and see you next time. Bye.